This video will show you how to do problems 11 through 15, pressure and depth in static fluid questions. So we're going to start with number 11, and number 11 we have a container, and mercury is poured into it, and then ethyl alcohol is poured in on top of that, and the height of the ethyl alcohol is 1.10 meters, and the air pressure at the top of the ethyl alcohol is 1 atm, which is 101,300 pascals. So they want to know what is the absolute pressure at a point that is 7.10 centimeters below the boundary. So right in here, and that depth there is 0.0710. What is the pressure right there? Okay, so the equation that we're basically using for these 5 problems, pressure, is density times gravity times height. That's going to be your equation you use pretty much for the whole thing. So the top pressure is just given to us, 101,300. And then we'd have to take the density of ethyl alcohol times 9.81 times the height, which is 1.10, and then we have to add the density of mercury, whatever that is, times 9.81 times 0.0710 is the depth of that. Add those all together and you're going to get your overall pressure in pascals. Yes, you're supposed to put it into kilopascals. Okay, problem 2. A rectangular swimming pool. We have a rectangular swimming pool, and it tapers off down to the deep end here, and this tapers off at 11 degrees, and this is 15 meters. We're trying to figure out what is the pressure at the bottom of this pool, and of course pressure is going to be density of water, which we know is 1,000, times gravity, 9.81, times the height. So the hard part about this is you got to figure out this height. We can use a trig function here. We have opposite and adjacent, and I'll let you figure out how you can figure out that height to put that into the equation. That's problem 12. Okay, problem 13. The density of seawater is given to you. A submarine were to dive to a depth of 11 kilometers, which is actually 11,000 meters. What force would the water exert on the submarine's circular window? So we remember from our last unit, pressure equals force over area. Of course, now we know pressure is density times gravity times height equals force over area. We're trying to figure out the force. Right? Yeah, what force? Yeah, force. So force would equal density times gravity times the depth, the height that we're under the water, times the area, and it's a circular window, so the area of a circle is pi r squared. So you can plug everything in there and figure out your answer. That was problem 13. Problem 14. We have a submersible pump. It's put in the water at the bottom of a well and is used to push water up through a pipe. What minimum output pressure must the pump generate to make the water reach the nozzle to ground level 75 meters above? So again, pressure is density, and this is water, so 1,000 times, so we have density, gravity times height, so 9.81, and the height I think was 75, so pretty straightforward. You need to put that into kPa. And problem 15. Intravenous feeding, the nutrient solution is given a density and is 0.610 meters above the patient lying prone in the hospital bed. The solution can just barely enter the blood in the vein. What is the pressure of the venous blood in centimeters of mercury? So pressure equals density, gravity, height. The density was 1030, gravity is 9.81, the height was 0.610. That'll give you the pressure in pascals. You need to convert to not millimeters of mercury, but centimeters of Hg. Hopefully that will help you solve the 5 static depth problems.